Okay, Bob, would you introduce yourself to our crew, please?
My name is Bob Morley from Loy Instruments. I'm the branch manager of the Cleveland office. A little bit about the company. The company was founded in 1937 to serve the heat treat industry. Our company, we service, we can do projects on heat treat ovens. We can do wastewater, pH. Process control is the primary focus of the company. We're not much of an HVAC company. We felt that when we came to Cleveland in 2003, there's enough good HVAC houses to fill that bill. We came to Cleveland to fill the process control side of the business when Honeywell asked us to come into this market. Although the one product that we do share that we're going to talk about obviously is some of the Flame Safeguard products, some of the concepts, that's what we're doing. I started with Honeywell in 1978, came into the HVAC side of the business in 1994, and I've been doing process control since 2003. That's what we're doing here tonight. Now, if there's any questions, you just stop me as we go along, and we'll go through some of the concepts. Everyone here, do you all work on flame safety, or is it just kind of an overview for you? Hopefully you might know it like the back of your hand. Maybe you don't know some things. Hopefully you'll come away with something. Flame Safeguard as a product, it operates, it looks at limits, it looks at controls, it looks at your flame, but as we have up there, the first and foremost is safety. It's always checking, just some quick examples. Quick here is an example. When you power up a unit, it's always looking to see if everything is safe. If there was ever a flame, I don't have it wired up, we'll do it later. But if it ever senses things like voltage in the wrong terminals at the wrong time, it will go to alarm. If you have a flame, when there's not a call for heat or flame, you will go to alarm. So it's always, like I said, the first and foremost is safety. That's what we're trying to do, and to make sure that it's used properly. Of course, like any other system, if somebody bypasses something, you put yourself at risk. I've seen where people have nuisance problems if you get into dirty environments, as an example. Guys will jump out, first thing to go is air pressure switches. They get clogged up, they cause nuisance shutdowns, so what do? They jump them out. Bad idea. If you go to the next slide, that's what you're trying to avoid. That was a furnace explosion, not sure where, but I've heard stories. I've been into places where, it was a couple of years ago, one of our customers, and they made me sign in. Never had to sign into this company before. Went to the side, the plant manager caught me going in the side door. He says, no, you have to go and sign in. I've never said to sign in before. So I went in we had to look at a problem. I thought, my God, it was huge. There was a big oven, a big belt oven there. It's gone. They said, well, it blew up.
No.
Yeah, I mean, it was gone. Nothing. Everything was gone. To make it worse, they had visitors there. So it's bad when something blows up when you have visitors there. So that's why I had to sign in. Now you go into a lot of places, they want to make sure if something goes bad, that they can account for the people that were inside. So, okay, you can go to the next one. That's another after. I think that was the aftermath of the slide we just saw. You go to the next one. Just some bad things that happened. You ever hear of River Rouge?
Oh yeah.
That's River Rouge. Right there. Of course, that was a coal-fired, manually operated system, from what I understand, and it was just a cascade of mistakes. This operator's supposed to do this, that operator's supposed to do that. Something went wrong, and that was the end result, and I think it was either 7 or 8 people died. Terry, how are you? Join us. Next slide. Some of the agenda we'll talk about is, we'll go through little gas trains, sensor, maybe not in this order, sensors, the difference between primaries and relays. Not gonna talk too much about code, show you different control and modulation. We'll talk a little about the displays and valve proving systems. Have you done anything with valve proving at all? Anybody? No? Okay, we'll touch on that. You can go to the next slide. Conduct combustion basics. And so basically what you need, you have a fuel supply, air supply, control valve. You don't have to have a control valve for air. Sometimes you don't have it. It's just you're using combustion air from a combustion air blower, or it could be just atmospheric. You don't have to have a real mixing device unless it's natural mixing. Ignition source and your flame detection. You know, it's pretty much cover all your combustion basics. Go to the next slide. Typical fuel train. And it doesn't have to be like this. This happens to be a double block. It does have your vent valve. Go to the next slide. Controls that supply, regulate fuel pressure, monitor fuel pressure, pilot gas and main burners. Next slide. You have your, to make things easier for testing, here's your pilot line. If you want ball valves on either end so you can test, or you can isolate different pieces. You see there is a regulator. You always want to have a separate regulator for your pilot and your main. You can go to the next one if you like. What it does too, if you want to do long-term shutdowns, that's where your valves come in handy. You can also red tag it if you have that availability, if you have to. Have you guys ever done that, where you declared that this unit or this system is not operable? And I know I took a class once in ventilation. We went up to Canada, in Toronto, and they were more stringent on their regulations on how they do things. And I can't prove this one way or the other, but the instructor told us, if you were a contractor and you knowingly went by a problem without saying anything or let it go, if something went wrong, you could be held liable. That a problem or serious condition existed, you did nothing about it. So anyway, we go to the next slide.
What's SOV?
Pardon? Oh,
SOV?
Safety shut-off valve. Strainers, good idea. Some people have them, some don't. Collects water, dirt. Some people go as far as putting a strainer in as well. Not a strainer, but a filter, I'm sorry. If you've ever seen them, it's just packed with, almost looks like insulation material. Next slide.
Pipe shavings.
Pardon?
Pipe shavings.
Yeah. So it protects the regulator, protects valve seals. I suppose if you had something large enough, if it got through somehow, it could wedge between a valve seal and keep a valve partially open to let some gas flow through, although I've never seen it. I guess the possibility exists. Go to the
You got a building supplied off of a natural gas well on the property, and they don't maintain that, and they overflow the sludge tank, and will come through all that.
Well, I know of one, this is a few years back, a contractor was working on a job, and somehow oil seeped into the natural gas line.
The red oil out of the meter too, it's red oil in your drip leg, that's where it's from.
Well, I don't know if this is from a ground source, but it contaminated everything. So they replaced everything, same days, all the parts that they could get, regulators, valves, put everything in new, and it happened right after they fired up the system. It just came through again. I don't know where they got the parts, they didn't come back to us. We didn't have everything, but at least we tried to get them up and running. But anyway, there's your regulators, the pilot regulator, usually that's, you can get, you know pretty much by the size. Your main regulator is important, because you wanna size that to your burner, and you wanna have a regulator for each burner. So, rule of thumb is to size any regulator, all you need to know is the pipe size, the inlet pressure, and the desired outlet pressure, and you can size any regulator. You don't want to have it too large, or you don't want it oversized, or you don't want, or you will not get good control. Or you don't want to have it, I think you want to at least, you want to have about 50% more capacity in the regulator than your burner. Next slide. So it just, you know, typical inlet pressure, outlet pressure. If you're familiar with the Maxitrols, they have a fixed orifice, can't change anything. It's usually designed for predetermined BTU output, as opposed to Norgas or Itron. You know how you can replace the orifices? Have you ever done those on regulators? Yeah. So you can use the same regulator body to change out orifices depending on your BTU demand.
Are there different methods for slow opening regulators besides bleed orifice?
I don't.
I've never thought of that until just now.
We'll find out.
We'll talk later.
Okay. Write that down for me so I don't forget. Next slide. Solenoid valves, usually the solenoids are on the pilot line. Although if you were using a double block, you could use a slow open valve or a valve that has proof of closure, and you can put a solenoid in there, as long as you have that, if you're fulfilling that double block requirement. Oh, this has a vent valve. A vent valve is not required on NFP 86, which is industrial ovens and furnaces. Do not have to have a vent valve. You do have to have it on NFP 85, which is boilers. So it's just so you know that. Next slide. Okay. A lot of manufacturers, they have cleaning, they've gotten away from being able to replace main valve parts. Maxon is an example. You can replace the solenoid that operates the motor that operates the solenoid, and there's you can replace the switches. But you, once you start to touch the seal or the plug, they don't let you do that anymore.
The hydro motors, the Honeywells, I don't think they let you get like oil for them.
They've gotten away from that because now
I think Red Hat might still.
Red Hats will let you. You can replace the
oil.
diaphragm seals. Now I don't know about the hydro motors.
Yeah.
Yeah. I'm not sure. I know Honeywell won't, because now it's a liability issue. Once you start to take that valve apart, somebody puts it back together incorrectly and something goes wrong, now it's a liability issue. If something happens. Go to the next one. A higher gas, low gas pressure. Well, some people like manual shutoff, or manual reset, I'm sorry. Some people like auto reset. But if you have those, and you have the right controller, and you're having a problem, and you suspect it's a problem, we get a little further in tonight. I'll show you a tip you might be able to use to, if you ever run into a troubleshooting issue where you suspect it might be a gas pressure issue, or any safety for that matter. There's a little trick you can try to see if that's giving you the problem. Next slide. So gas pressure switches, if it gets too high or low, if it's misadjusted, Sometimes you might be right on the verge of tripping if somebody hasn't thrown a manometer on the gas line to see, well, what pressure are we supposed to be operating at? Always inspect for jumpers too, because some people, they'll put a jumper on there and forget about it, and that could be bad. So,
You could end up in court.
oh no, yeah, I've heard some that too. Honeywell used to have gas ignition training for residential guys, and it was quite successful years ago. They haven't done it in a long time. But we had 2 instructors, and they used to always emphasize, when you go in on a combustion system, scratch that name off of that manufacturer's list and put your name on there. Because if you're the last one in there and something happens, rest assured you're gonna be on that defendant's list, up towards the top. They're gonna start with the guys at the deepest pockets, but you're gonna be on that list. So you would just wanna make sure that it's done properly. Okay, next slide.
No complaining there.
Shut off valves, just want to make sure you have good shut off, open on command. Your larger valves will usually have a window, sometimes an indicator light, but like the Honeywells, the hydro motors do too. Don't they have a indicator that's showing they're open or closed? The Maxons do.
Yeah, I guess so.
They
I
got
know.
the arrows, don't they, on the side?
I remember now.
The Crom Schroeders, I know you have to get, to buy a separate part that goes on the valve to show you if you need a position indicator. But depending on, the size of the burner, it's mandated that you have a, indicator to show the position of the valve.
Fire sprinkler system, they have it says open or close when you put that.
Oh, yeah, and it's, I know it's on the OS&Y valves, or if they have the gate valves, it would have a window. Maxons are like that, they have that open shut, indicator. So, okay, next slide is, now if you have a modulating burner, you'll have a flow control valve. A flow control valve does not have, usually a flow control valve does not have 100% shut off. Usually there's blocking valves upstream. That's just to control either fuel, air, or both. I have a demonstration with that. This will be our flow control valve for this model. I'll show you what that'll be later on tonight. We'll show you what's happening there. But that is your flow control. You don't have to have it, but if you need it, that's usually it's the last valve in the pipe train. Next slide. And it just controls air, fuel, and or both to the burner. Sometimes it's on the burner. Usually I see a valve. I've never seen it on the burner. Of course, I don't work on a lot of burners, but I'm sure they're out there. Next slide is, okay, now some of the principles. You go by that. Next slide. Okay, it started with the burner controls. Starts and stops the burner automatically or manually. Does it in proper sequence. Supervises all your circuits. And you're either controlling, if it's a burner, either if it's steam, it's pressure. If it's hot water, it's temperature. Should always have, if you see anything without a limit, anything that's where there's a risk of an explosion, overheating, always look for a high limit. Should have a high limit. Preferably one that locks out, because that's your last line of defense in case something goes wrong. So ideally, you'd like a limit, either pressure or water, or temperature, I should say, or it could be some other engineering unit, depending on what it may be. But you want a limit that has a manual reset. They regulate the burner firing. Well, it doesn't actually regulate the burner firing rate. Usually that's done by a controller. With a flame safeguard unit, if you have a modulating system that does modulate to high and low fire before light off, all it does is it bypasses that control to make sure everything's working properly. But it's not, the unit itself does not regulate the firing rate.
So, I have a quick question.
Sure.
So like some of your burners, they'll actually modulate to high fire for the pre-purge, and then it's gotta wait for the timing doesn't start until it makes an end switch.
Yeah, we're
and
gonna,
damper motor.
yeah, we're
And
gonna,
then,
actually, we're
and
gonna,
then some burners I've worked on boilers, they don't, they'll just sit there at low fire and do their pre-purge at low fire. There's probably a size break on BTUs.
it depends on the manufacturer. I read about that. If a modulating system, if it's been determined that it's safe to light off in any position, high or low, you don't care where you light off. But if it's not safe to light off in, let's say, a high fire condition, then you have to at least be in low fire.
Right. And that's what they normally do, but it's
Yeah.
the pre-purge. And the reason I thought about it was I've worked on some of the engineered air rotation units.
Okay.
And they'll have that, I can't remember what it's called, but they'll run for like 10, 15 minutes, depending on the size of that UG exchanger. Some of them are 10 minutes, some of them are 19 minutes, depending on the size, just to pre-purge that thing.
Oh, okay. When you get to, and we'll talk about that, why don't you talk about it now? When you do, are you talking about your pre-purge, your
Pre-purge, yeah,
combustion?
before you try to light off.
You have to have 4 air changes.
4 air changes.
That's where your lower explosive limit should be. So you want to have at least 4 air changes as a purge time. So you would get the volume of the combustion chamber and divide that by the CFM of the outlet of the fan, if you will, to make sure that you have 4 air changes before you light off. And in the event that there's unburned fuel or some combustible inside the combustion chamber.
So the ones that just purge out at low fire, with the damper at low fire, they've determined that they've got their 4 air changes at that much airflow.
Somebody designed that in. But if it was a real critical application, like I've seen some big oxidizers, you could probably put a sensor in there if it's that critical. I'm sure if you were in some chemical facility or where you're refining oil or in the gasoline or something like that, they'd probably put some kind of a sensor in there to make sure that, okay, we've done 4 air changes, but we want to be really sure that it's.
Right. I just wondered if there was like a size break or.
No,
the 4 air changes is probably
The 4 air changes is a standard, but the size of the BTU of the burner, and where you light off, that's determined by the manufacturer.
Yeah, most stuff just lights off at low fire.
Yeah.
What's an example of an oxidizer?
When you get into certain factories that manufacture the byproducts or poisonous or hazardous to health, when they vent it in the air, they will duct it back to an oxidizer. Basically, they just burn it off before they exhaust it back into the atmosphere. Yeah, it'll be a small unit. You've seen some large ones. It's usually a large unit that sits on the side of the building, and they just dust their exhaust back to it just to burn anything off that
bad
hits.
stuff,
Yeah. Sometimes it's just because the odors may not be hazardous, but
Might be
they could be in a neighborhood where people just don't
H2O.
like smelling whatever. Yeah. Okay. What are we here? Next slide. Run the next one. The functions of primary control. Like we said, when you first power it up.
Been like that for years.
Power it up there.
1 inch.
It's all, as soon as it powers up, it's gonna look for any unsafe condition. If, well, I don't know.
Pre-existing flame.
Yeah, I don't have the right amplifier in there. I could put it in there. If I had the UV one in there, I could hold a UV lamp up or hold a flame up to it, and if it senses a flame in the off condition, it will go to alarm. That's saying that it's in an unsafe condition. So go to the next slide. Typical burner control, it checks its own components, and we'll pass that one. Usually you have a control system, they may control everything, or some type of on-off controller. In our case, we're just gonna have switches. You have your limits and interlocks that are wired to the control and your detector. And that's pretty much it, that's all that it's doing. Like, other than the fact if you have a programmer will drive the unit to high and low fire. Your larger systems will have a proof of closure switch on the main valve. We kind of have them layered in here. I'll show you what will happen if it's, that's one thing it also looks for. When you have a proof of closure switch on a gas valve, it has to see a closure within, I think it's 1 second or 2 seconds. So when your call for heat has ended, it wants to see that main valve close within 1 second. If it's open during an off condition, it will go to alarm. This particular unit I have in here now does not have the proof of closure function. We'll go through that with one of the other ones a little bit later on. Any questions so far?
What's with all the jumpers underneath there? Let you like clip them for certain options? Can you put them back
The jumpers
inside the controller?
on these.
Yeah.
See the jumpers in here. You can operate any control up to 200 hours with a jumper uncut or cut. You can always solder it back if you have to. But after 200 hours, if you try to remove a jumper or put that back in,
It doesn't matter.
It will destroy the unit, and you will have to
Oh,
buy
really?
it. Oh yeah, no, you will get a fault code if you don't have a display. You get a display. It will give you a fault code that the jumpers have been changed, and you will have to purchase a new unit. On this unit, depending on what it is, you can have your flame phaser action, which one do I have here? It's a 7895. This has an airflow switch. Depending on which one you're using, there are jumpers, how you want the airflow switch to work, your pilot trial time.
Continuous retries?
Yeah, well, continuous retry is, what that will do is if you lose your flame during a run period, it will retry. But if you don't succeed in we'll demonstrate that. If you don't succeed in lighting the pilot, you will go to alarm and it will not reset. Once these go into alarm, you have to manually reset them. They will not reset on their own.
Or put a jumper on.
Or put the jumper on. Well, does anyone remember the old RA890s?
Yeah, I think if you jumper that reset button, like tape it down, it's one of the things it's probably looking for. It's just gonna
Well, remember the old RA890s? That guys used to put a matchbook under the 2K relay, so you didn't have a nuisance shutdown.
Yeah.
Now, the only problem with that, if you lose your flame, now you just have a gasket stuck open, waiting for an ignition source. And there were many explosions because of that. I've never seen one myself, but I heard some guys, they've even had creative, and had shop guys make wooden shims to actually go under the relay, to hold it in open valve open.
I use dead spiders. Pretty safe that one.
So, but they're still out there. All right, next slide. And then your phases of your burners. Here's the burner in the off position. Your valves are closed. Go to the next one, and you open the pilot valve, and you put a spark. You got a little flame there, and you go to the next one. And once you've proven flame, you go to the next slide, and you got a big flame, and now you're up and running, and you have heat, or hot water or something. And next slide. And then you have draft, go to the next one. Everybody's, atmospheric, you're just heating up air, it's going out the stack. And next one is forced air, so with forced air, get a nice big hot flame in there. And the next one is a induced draft. So still somewhat of a power burner, you're still pulling air through there. Probably doesn't get quite as hot as that power burner, but you're exhausting that combustion gases. Next slide. Okay, there's your R890. Like I said, there's still a lot of them out there. We're going to show you if you ever come across those, how to replace those, especially if you have a standing pilot. Do you ever see standing pilot systems anymore? Not many.
Okay, very rarely.
There's a couple out there, but we'll get to that in a moment. But go to the next slide. Is and all they're looking for is inputs, and your inputs are usually you're going through all your safeties and limits, and your safeties and limits could be whatever you want to put on there, whatever feels, whatever's been designed in, or whatever you feel that would, if you want to add a safety or limit at any time, there's no harm in that, other than you have high limits, you have controllers, you have high and low gas switches. It could be an oven door. The oven door's got to have an interlock, it's got to be closed. Your combustion air blower, some people put them on the limit string. If I had a control that had an input for an airflow switch,
Yeah.
I would prefer to put it on there simply because it
The
locks.
enunciator will tell you it's the airflow.
Well, Honeywell had an enunciator. I don't know if you've ever seen them. They used to have what was called an S7830. You had to home run a parallel wire from each safety that you had back to the control, but because of lack of demand, like everything else Honeywell does, they don't sell a gazillion a year.
But I mean, like those there, don't they have a separate set of contacts for the airflow proof?
Yeah, airflow, yes, but not on all models, though. Not on all, the RM7890 does not have an airflow input switch, or input terminal, I should say. It's the only model that does not. It was as a model. Well, we'll get through that, because I'm going to go through these one by one through the more popular controls. So you have your controller, your inputs from your controller, and a controller could be an on-off switch, could be a thermostat, or it could be coming from some type of building automation system. It's still providing an on-off signal to say, start to burn. Your limits, we talked about the limits, very important. Make sure they're all, they're not jumped out. High limits, if you have high limits, you want to have a manual reset if possible. You don't want, but it's a good idea. Next slide. Some models, they have a burner motor output. You want to operate a motor contactor. It'll operate your motor. Once it starts that motor, then you want to, that's when it's going to start to look for your combustion airflow inputs. Now, there are some controls that they call it a dynamic airflow switch, and it will, in a lot of cases, guys will jump out the, no, I'm sorry, they will start the fan before the unit starts up. They'll press a fan switch, it starts their combustion air blowers, and they're up and running. For some reason, and I don't know why, I'm sure there's some regulation behind it. Certain systems will not allow airflow before the flame safety unit calls for airflow.
Right. prevents people from jumping the switch.
So,
Furnaces on.
yeah, they want to see that,
They wanna see
they
it
wanna
open.
they wanna see an open airflow switch before there's a call for heat.
Right.
And so certain units, they have, it's called a dynamic airflow switch. So the next slide is, once you've proven everything, you get your ignition and your pilot valve at the same time. Next slide, and then you will get your main flame signal. Intermittent pilot, your pilot will run during the full time that your main valve is open. Intermittent signal, intermittent valve pilot, your pilot valve will go out 10 seconds into your run period, and we'll see that a little bit later as well.
Interrupted or intermittent?
Interrupted the pilot valve will turn off 10 seconds into the main valve. Intermittent.
Most things are interrupted, intermittent.
Pardon?
Interrupted is what we see most of the time.
Yeah,
It just runs for 10 seconds and goes down.
Usually you'll see that on a larger system.
Intermittent, yeah, it'll stay running the whole time.
Yeah.
Oil burners, I think, are intermittent all the time.
So go to the next slide. And then it's looking for a good flame signal, either, and we'll go into depth a little bit about those. Typically you have UV, infrared, or rectification. Honeywell did have a visible light sensor. They discontinued it. I don't know what it was used for. I don't know if they made them for, I saw panels, I was watching a show on if it was Discovery or History Channel, and they were showing theatrics in Vegas, how they do light shows and this and that. They had a panel open, and they had a lot of flame controllers in there. And so I'm assuming somehow they were used to look at the visible light in the show to operate certain segments of it, because I don't know where you'd want a visible light sensor. That could be dangerous under the wrong conditions, but that's only me talking, so. Anyway, next slide. If you're familiar with old school controls, here they are. There was an R7023 replaced by an RM7823. All that was a flame switch. Have you ever been in a shop where they have flame, they have the flame curtains over furnaces to burn off any existing gases? That's what they would use. It was used as a permissive in cases too. When it saw a flame, all that unit was used for, if it saw flame, it was a bare bones unit. These all look the same. When it saw flame, it would close a set of contacts. It didn't operate valves, did not operate ignition transformers, did not have any inputs other than the flame itself. The only outputs on it were 2 relays, and they called it a flame switch. Then you had the 485s. This was more of an industrial manual start. I don't know if you have worked on the manual start ovens or furnaces. You have to hold a button to actually start it. You can hold it for up to 15 seconds or longer, and it would just sit there and spark, open up the pilot valve until you were up and running. And sometime, once you got the pilot running, a guy would go over and throw a manual Maxon valve. If you've ever seen those with the handles, the manual handles, you ever seen those?
Yep.
Yeah, okay. Usually you won't see those in a heating application or commercial building, I should say. Those were usually on industrial ovens. RA890s. Now the RA890s that's kind of the animal behind that. They use those for everything. They use those for multi-burner ovens. They used, if somebody had to have an airflow proving switch, years ago, a lot of that was designed in by whoever the manufacturer was. Eventually they came out with the R4795s where you could put a purge timer in.
What were the ones with the rotating wheel on there that would tell you?
That was the R4140s. And that's that one, and with the cams.
Yeah.
Yeah, that was replaced by the RM 7800 series. And we'll talk a little bit about that, but the R890 they would use those simply because of the cost. Everything was always done because of cost, okay? So they would put maybe, let's say this was your limit string right here. They would put a purge timer in, an off-the-shelf purge timer. They would put before you went to start, rather than have it designed into the circuitry of the unit itself. They will design that in. If I want to drive the high and low fire, there's guys that would sit there and draw up relay logic to do high and low fire proven to drive one of these. And it's nice because I guess it would keep the cost down. But if you'd never worked on that, it was a troubleshooting nightmare. Some guy would come in and you'd have to figure out, how does this work? And I guess that's what separated the men from the boys. You'd have to pull out some print with all this wiring on there, and hopefully it wasn't added to or deleted from, because, well, do you think you've ever been to a job in a panel where somebody put something in that wasn't on the print? No, that never happened. Gee, where is this coil? Where does it go? What does it do? So, excuse me. Then they came out with the 7795s. It was a nice concept, but the problem with the RM 7895 that replaced, you can make this either UV or flame rod or an infrared detector by changing out an amplifier. The R7795, if you bought a UV model or a rectification model, that's what you had. Well, I want to switch it to UV from rectification. Well, you want to switch it, you've got to go buy a new one. And this one will sit on the shelf until you need it. Then you had the 4140s, which was Terry you were talking about with the cams.
That's that
And
brake
those
pin
were,
design.
yeah, now one thing about those is you had the motor in there. Let's say you were halfway, you had to sit there and wait until it went all the way through and all the way around. And let's say halfway through, well, I want to start over again. You could power it down and power it back up, and it wasn't like it reset everything. You had to wait until that cam went all the way back around again. Whereas if you get like a 7800, well, I'm halfway through the start cycle. I want to stop. You power it down, power it back up, or turn the power. They call for heat, you turn it off, turn it back on, and you're going to start over again.
It had that purge hold switch too, like these new ones do.
And then the BC 7000s to replace that. That was the first solid state unit that replaced the R4140s. Remember that? It was kind of the rectangular blue box with the PM program chip. So it was kind of somewhat of a base unit, and then the program chip would tell you, well, you know, I do have high and low fire proven. I have a 60-second purge time. And you can change the amplifier cards in that as well. So, but now all of these are gone now. So they've been replaced with the RM7800 series. And the nice thing about the new ones, they all use the same subbase. Some of the terminals most of the terminals are the same, except with the exception of a few of the important ones. Next slide. So here, if we went through that triangle, you had the 7823, that flame switch I was talking about. 7885 is a manual start. 7890, which is your basic control. 7895, which has it has your airflow input, blower output. 7896, we're not going to talk about that much. The 7895, I brought up what's known as a 7897. The only difference is it has a proof of closure input, and it has a programmable post-purge. And it's actually a nice control. It's a little less expensive than 7895 with more features, a couple more features anyway. I kind of like it. You don't really have to rewire anything, except you have to add a jumper if you're replacing one from the other. And then you have your programmers, your 7840, forget about the 7888, that's another industrial control, but the 7840 and the 7800. And the only difference is, grab one here, you'll see a 7800, all the model numbers are on the back. So unfortunately, if this was sitting in a sub-base and you did not have a keypad will show you, you could go through the diagnostics, and it would show you, it would tell you what the model number is, the actual model number. If you did not have that, you would have to take the unit off to see the model number behind that. None of the units are equipped with a keypad, except the 7800, 7840s, 95s, and so forth. They do not have a keypad. Only the 7800 has a keypad.
Tell them about the keyed sub-base.
Oh,
The
well,
OEMs?
yes. Well, let's see, do they have it on here? Yes. Some of them, you have to be careful. I know Cleaver does it. Some of Cleaver's, Fulton, some of Cleaver's though, you have to be careful with, because some of they may have models that are specific to their control. So if ever you have one and you suspect it's something you can't find, give me a call and I'll research it. But what they'll do is they'll key the sub-base. So you can't put it in or key the control so you can't put it in a normal sub-base unless you trim one of the ears off of it and go in there. You just want to make sure you have the same functionality. Also what Cleaver did, I don't know if they're still that way, is the keys here were offset in different positions, so you couldn't.
Oh, you couldn't even plug them.
You couldn't even plug that in, so you had to buy theirs. They actually had a replacement kit, but I don't know if they've done away with that, but.
Now, that plug-in enunciator, all the information's always in the base, right?
Yeah,
So if you carry your own, you
the
can plug it on.
diagnostics, a keypad is, you can look at the history, you can look at the current function while you're operating, it will show you your flame signal, your condition. You can look at the position of the terminals within the unit. And the history will go up to the last 6 faults. And that's held within the unit. The keypad itself is only a diagnostic tool.
But it doesn't give you time date, it's
No.
which start it was on.
No.
And the
It'll
start's,
give you
the start's still only 4 digits?
the
How many starts? Like it tells you like what cycle something happened?
oh, yeah.
So
It'll
the
tell
number of
you-
cycles?
It'll tell you what cycle it was on. No, I think they moved it out from 4 digits, I believe.
Yeah, cause
Yeah.
at 9,999,
No,
it just sat there and you
Yeah,
was
and
stuck.
that could not be reset. That was
Right.
set in stone.
And it didn't roll over like an odometer, you know.
Yeah,
No, and it'll show you the time, how many on-off cycles you had. And
It'll tell you at what point in the process it was
Yes.
too.
okay, next slide.
Seconds in.
Your purge timer is, FireEye had on their cards, like the MP230s or MEP230s and so forth. You can set those on the programmer card. Honeywell has a purge timer card, and that determines your purge timer. You can change the purge timer every time. That's not going to cause a problem. Likewise with the amplifier. If you want to go from any type of flame supervision, you can go to whatever type that you want. It's only the jumpers, whether you cut a jumper or do not cut a jumper, we're after 200 hours, you're kind of set in stone. Okay, next. So safety shutdowns, an alarm, the only time you'll go to an alarm is when you have a flame fail, or if you lose your pre-ignition interlock at the wrong time, or if you lose your airflow switch. As an example, this one. Okay, so we have flame running, and we're going to. Now, see, that's attempting to relight, because I have a relight amplifier, I don't have the jumper cut. And if you don't relight, it's gonna go into alarm.
So the green light is alarm,
I have it on the alarm terminal.
okay.
So, once it goes into alarm, you have to either manually press the reset button, or if you have a system, you can wire back to a,
Momentary
they
push
have
button.
they have a remote reset module that you can use, or you can wire back to your keypad. There's a set of terminals on there. Normally open spring loaded push button to reset your alarm. False flame detection, your open lockout interlock, loss of flame, or if you don't light off during pilot, the most common fault code you'll ever see is a fault code 28. That means you didn't light off on pilot. Fault code 28, it's kind of like the check engine light, because it can be caused from a number of things. You could have a bad ignition transformer, bad ignition rod,
Cracked
no gas
insulator.
pressure, bad solenoid valve.
Pilot blowing the flame out.
Yeah, it could be, there could be flames getting blown out, so it could be a whole host of problems. Next slide. So we did that, safety lockout, pour flame, ignition, faulty detection system. And next slide is, a random shutdown failure to ignite, detect pilot. Usually you don't lock out. Usually when if you lose your flame on the main burner, once you open up, if you have a good pilot flame and you lose it on the main burner, usually it's because of gas pressure, something changed. Because if you're losing it at that point, something happened, and probably something happened in the dynamics of the gas delivery where you lose it on the main burner. Next slide.
That main burner would take almost all the gas from the pipe and nothing left
Yeah,
of the pipe.
because especially on intermittent pilots, when you're on intermittent pilot, especially with a flame rod, you're sensing off the flame rod now. Usually it's not an issue with UV because it has that wider angle, and it's hard to lose a signal. You have to have really something going wrong with a UV signal before you lose it and get a little flame signal. So what will happen is you will, on a flame rod especially, is if you're fine in pilot, that somebody cracks that main valve, and all of a sudden you lose that pilot. Pilot flame goes bad. That's the first thing I will tell people is take your, they're having a problem and that's happening, take your number 9 wire off. Number 9 is always your main valve terminal on your Honeywell flame safeties. Take that wire off and cycle your system. Because when you're up and running, the units don't care if the main valve is there or not. It's just putting output. All it cares is that it sees a flame. It's coming from your pilot. Doesn't care if there's a main valve there or not. And if you lose your flame, if you put your main valve terminal and you're still running, you'll know there's something's wrong with the regulator, the fuel supply. Something happened when you open up that main valve and it's.
When the main flame lights with a woof, blows it out.
It could happen too.
What's the voltage for, main flame, so on, 24 volts?
Oh no, these are all line voltage.
Oh,
Yeah.
120?
Yeah, 120. You're not allowed to have a relay in between, or at least not supposed to, because if you put a relay in between your gas valves and for some reason it gets the contacts get fused together for some reason,
Yes,
they
yes.
overamp them, or you don't want to have anything that could enable the valve to stick over.
Those relays have been tested and safety certified.
All of Honeywell's, they have a a fusible link in there, if you overamp them, it will burn up the link, it'll destroy the unit, but, you won't have a, you won't have the risk of the valve sticking open. 220-volt valves are all legal now, or out, you're not allowed to use those.
Because if you could have an accidental ground,
Yeah, and they said it only took half the voltage on one terminal to do that, so they said they eliminated that altogether.
it's not too.
So if you ever see one that, out there, and they have to upgrade, or you have to do work on it, they have to, work on the boiler, they have to upgrade that, they have to bring it up to code. And then shutdowns, loss of voltage, I don't see too many loose connections or splices, you would hope it, you know, have that, or damaged wire, I mean, damaged wire, or opening of non-critical limits. And that could be, like we said, any limit that you string that you put in there, you could put anything you want in there that you feel is necessary to make something run safely. So, you can use it. Next slide. These are the programmers. Next slide. Oh, the basic rules, 120 volt. If ever you suspect you're having a power problem, if you measure earth ground to L2, you should see no more than 1/2 volt. If you see anything more than that, your customer has an electrical problem. They need to call an electrician. That's not supposed to happen. They could have a bad transformer, or somehow voltage is getting in there somewhere. But between earth ground and L2, you should have no more than 1/2 volt. The guy called me once and said, well, he measured his.
I've run it-
He
I've
was
run
getting-
into
no, he
that.
would- no, he said he had 48. Maybe it was low amperage voltage. I don't know where it was coming from. But he said he was getting weird, messages on his display.
Yeah, Giant Eagle, they were getting 15 volts from, earth ground to, neutral.
Yeah, no, can't have that. That's bad.
So you just peg L2 to ground, right?
You could do that, well, like at
It's
home. I
not
could
the
put that-
same thing.
Well, ideally, it's supposed to be grounded, throw your own ground in there.
Silver
Did you ever have to put, did you ever see guys put it grounded manually, when they just get on top of a big A-frame later, ladder, one guy hold the rod, the other guy just tap, tap, when they, especially when you have a floating ground problem, you have to have a guy come in.
Put those in, and it's usually not tap, tap, tap.
No.
Rotary hammers with a socket on the end.
No, I
of it,
watch these
where-
guys do it by hand, really, a guy was on this huge A-frame, and
Yeah,
they.
fence post drivers, you know,
Yeah.
pipe with handles on it.
Yeah, so, all right, next slide. What is this one? Let's skip open. Oh, that's, some of the, problems you can have if you have bad voltage. Valves could stick open, contacts could short. So you wanna make sure you have good power. These do monitor for power. If it's, under volt, it will tell you that. I'm not sure about overvolt, I never tried that. I know undervolt, it will tell you that. Next slide is 240 systems. We talked about that, not allowed, go past there. Oh, next, sorry. Does a safe start check prior to starting. Again, it checks for all your voltages, it checks for flame, that you're not, well, it does that all the time, as long as the unit's powered up. Ideally, you'd like to have power on the unit. There is a separate terminal for power to the unit and a call to start. Ideally, you'd like the unit powered at all times, so it's actually looking to make sure everything's okay. Next slide. Safety interlocks, doing the same thing that the relays are doing. The only difference between a flame relay and a programmer does it's for a modulating system where it's gonna take control of your firing rate motor. Next slide. Let's see, there's your, safety interlock, your 4-to-1 ratio on air changes. And there again, if fire rate needs to be, if proof of, proof of high fire is required, it will do that. There are 3 models of, there are 3 modes of operation on the programmer. One does high and low fire proven. There's another one that does low fire proven only, and then there's one that just, if they're just operating a damper motor, it's just, it just goes open, close, and it's not looking for modulation. It's just for an open, close damper. All your programmers have proof of closure on the gas valve. They all have a proven combustion air input for your airflow switch. And you can use that airflow switch if for any other airflow that you feel is necessary, or if you want to know if you're exhausting air, you can tie any switch in there that you feel is necessary to operate that system.
Oh, like combustion
safely.
air damper, interlock, or?
Well, yeah, well, that's gonna,
You
usually.
got dampers on your combustion air, you wanna ensure
Yeah.
they're open before it fires?
Well, no, that's, before it fires, no, because, wait, that would be on your,
On the safety circuit?
you can put that on the safety circuit, unless you wanna isolate that, because if you lose it, during the course of, in the run period, you're gonna shut down anyway. Next slide. Proof of closure, saying anything over 400,000 BTU. Valve provings, and, well, we'll talk about the valve proving at the end. I have a slide for that to show you how that operates. Has anyone ever done anything with valve proving? Do you know anything about that? Oh, we'll cover that.
I've seen systems that had it, but I didn't
Yeah.
do anything.
And next slide. Okay, if a system cannot light safely at all firing rates, low fire switch will be proven. So it drives to low fire, it will not fire until your low fire switch is made. Next slide. Ignition trial shall not exceed 15 seconds. And your 4-to-1 ratio, that's to your lower explosive limit of your combustion air below 25%.
I'm talking about natural gas, right?
Pardon?
Oh, that's right, okay, never mind, I understood what it was saying.
Okay. Flame proving, you have to prove pilot, obviously, to start the system. Once you prove pilot, then it will open up the main valve. And you do, if it's, some require both. If you have an interrupted pilot system, you're going to need something that's gonna see either the pilot, the main, and or both. Because once that pilot cuts out, you're gonna need something to monitor that main flame. Now, like on a line burner in excess of 3 feet has to have a sensor on the far end of the burner. Now, I'm not sure if you can do that with 1 UV, but I know if you had just did one, if you had a burner that was, let's say that was a line burner, let's say it's,
The UV will see both.
Yeah.
It sees the pilot, and then it's interrupted, the pilot cuts off, but then it's looking at the main flame.
but now I'm not sure about UV, but let's say this was a burner, let's say it was 10 feet. And it was, I know if it was a rectification, and we had a sensor here, let's say the sensor's at the front end of the burner, you light that burner off, it's gonna flame, theoretically is gonna propagate to the far end, you'd have to have another sensor out at the other end to look at that flame. Now, the problem is, because if you put the same, if you parallel two, flame rods, you get the same signal back to the unit. So you would have to use another control, and all it would be is a slave to look at the flame, and you would use the alarm contact. You'd have the alarm contact with your, of the slave unit. You would have that in series with your start circuit. So if you went into alarm because it didn't see that flame after a specified time, you're gonna shut everything down.
I'm trying to remember how McLean does it. They do it with two modules. They
Yeah,
ground
no.
one of the spark rods, and they've got the sensor at the other end. They've got one on the pilot. It's intermittent. Pilot lights
No,
it.
I'm not
If it
sure.
doesn't see it at the far end, then it shuts
Now, I'm
it
not
down.
sure if you could use one of those, you know how they have those Bezos units that you could stick, one of those out at the far end that just has the dry contacts on it. No, well, I don't know.
The one with McLean's a two-stage cell. That's what they're using.
Well, even on their single stage boilers, like an LGB9 or something like that, they'll have two modules in there. If you ground the one spark rod,
Oh, okay, yeah, that's right.
they're looking for the flame sensor for the first module
Yep.
that puts the pilot gas to the pilot, but the main burner one, it's all the way down at the other end to make sure that all the burners have lit all the way across.
Okay, go to the next slide. You know, your valve requirements, if you have a system that calls for, your 400,000 BTU system, they are calling for the, redundant valves on both the pilot and the main gas valve line. You saw that a little bit earlier in the valve train slide. Closing time has to be 1 second on the main valve. Once the call for heat has ended. Visual indication on valves, on valves, 150,000 BTU or more. I'm not sure if these requirements are up to date, though. I haven't actually taken a close look at my NFPA requirements.
But they want double block on the pilot line too?
If it's a 400,000 or up, yeah.
I've never seen that.
Visual indication can be lights, can be a little indicator like the open and close flag, but you have to have some indication. Some manufacturers, like the Crown Schroeder and the Dooms, they have a nice piece that bolts right on the valve, and you can wire that up easily. Next slide, let's see, valve requirements. There, here's what you were asking is 100, 150. See, there's double block. There's one other button here. There's a double block. There's a double with indication. Indication 150 to 400,000, and your 400,000, and that's got your proof of closure switch there. Next slide.
You want the indication on the pilot line ones too?
No,
Just the main,
yeah, just the main valves.
just that the line can supply over those BTUs, yeah.
And you saw the layout earlier. There's your shutoffs, regulating pilot valves. Same thing here, and there's, well, they have a leak, now, well, I guess I could talk about it now. What they have is, if you have to have a vent valve, and go in between your blocking valves. So you're gonna vent that through the roof or out of the building.
Yeah.
And that can be and the concept was done for economics. Is how much, let's say you're out in the middle of your furnace or whatever is out in the middle of a room and the ceiling is 30 feet high. You gotta run pipe out there to get it up to the roof or get it out to the ceiling. I don't know the exact formula, but based on how, on the length, you have to increase the pipe size. So let's say you have a 3/4 inch valve here that's going to vent that gas. You may have to go up to
2
1.5
inches.
inches or so, 2 inches by the time
You're
it
gonna go
gets
100
out.
feet or something?
They have what they call a valve proving system, and right here, what they'll do, instead of that vent valve, they will put a pressure switch in there. And they will, the units, I don't have one here, but it will cycle those valves and look for, and it has, you have to know the, at least the Honeywell program, you have to know the, of your valves, you have to know the upstream, the downstream and upstream's, volume of the cavity, the length of the pipe in between, and the size of the pipe, so you know how much, the volume or capacity of gas from here to here. And so when they cycle that valve, you're going to, first you're gonna depressurize it, you're gonna close the valve, and then you're gonna say, okay, you're gonna open this valve first, to depressurize this, and you're gonna close the valve, and you're gonna wait a specified amount of time to see if this valve trips. If that valve trips, you know you've got a leak in this valve. So, and then they will do likewise. They will pressurize this and leave this closed, pressurize that switch. Now, you know if you're losing pressure, you're losing it out of here. Any problem there, and it will not allow that system to continue on with the start sequence. And actually, that's one way of, Honeywell doesn't do it that way, but some others do. That's one way of proving that you have a proof closure. If you have if you're losing gas pressure at one of these valves, you'll know that one of the valves is not
Well,
closed.
you catch it with the bubble test though, aren't you?
Well, yeah. Wait, you got a bubble test before you have your light on?
What's that?
You got a bubble test before every light on?
No.
Oh, okay. No, this is designed to test that every time it lights off, so you don't have to have a vent valve.
So is it on shutdown or is it on light off?
You could do it, it's specified, you can have it always before, always after, always before or after.
Okay.
It's an option they give you.
Is that-
When you set the unit up, and we won't talk about it too much, but you have to have a certain programmer that allows you, and you have to have a passcode, because you don't want anyone to go in there and change your settings. But there's a few programmable units that allow you to do that.
Is this gonna be UL or FM?
It is approved, yeah. Actually, it's FM, it is FM approved. Actually, Promschroeder and Dooms probably were doing it before Honeywell. Honeywell, like, you know, they always do things after.
And that gets you out of having to put in the vent.
Yeah, if that's an issue. Some people think that, you know, what the hell, just put a vent in and be done with it.
Well, I've worked in a lot of buildings that are negative in the winter time, so they got exhaust fans everywhere, and where they're venting it to, it just sucks right back in the building.
Yeah,
And they're calling you because, oh my God, we smell gas, and the fire department comes, and they stick their explosive
Yep,
meter
yep.
in the end of the vent, and they're like, oh yeah, that stuff's bad, replace it all, and it's like, hang on, man.
I got one better. This company was in business for
So,
how long?
some
That vent valve wide open, one
Some
inch.
people,
Blast
they
time.
had good ideas to annual testing of all safeties, interlocks. It's recommended that a bubble test be done on gas valves annually, but who does that? In theory, it's a good idea, but
Especially on the manufacturers that put them right down the bottom of the
I
cabinet,
know
with no
some-
holes there.
I know some boiler guys who said that if they had to bring everything up to code, they'd be out of business because nobody would buy from them. People just don't want to pay the money. So, well,
That's true.
I just say, somebody can make that determination
You
whether
at
it's.
least know how to do both.
Yeah. Next, annual testing, leak testing, you know, documentate, you could document that it's done, just to show some governing body that asks we're doing this. Next slide, we're to the end of this. Some of the options you have your keyboard display, you have your manual, your remote reset switch. You don't, in your keypad, you can always have your remote reset done
the
off.
things on the bottom, what are those?
Which ones?
The palm, those are the feet?
Oh,
Those,
yeah, those just,
Legs.
Legs.
yeah, that just
Oh, okay,
fits in
fine.
the control. Yeah. Okay, this is the last one of this, so we can go back to that other list of back to the directory.
Where's that?
Oh, nice, yeah, let's do it there.
Come out of that
Where'd
one.
you say Jim Shop was?
The,
Do you want me to go
oh,
back?
go back to the D drive, is that what it is?
Yeah, that's it. That was,
Oh, go to documents, there it is, okay. Okay, go to, 78, this 78, that little, this one, right there.
Under the
Yeah.
standing.
Yeah, 7890. Okay, this is the most basic of the controls that we're familiar with. You click on that one, or open that one up.
Trying.
Oh, okay.
Microsoft, make sure we're too fast.
F5, full screen.
Need some intermission music.
Martin?
Intermission. There you go.
Not good enough.
Got it, you're back.
Yeah, pretty much the only thing on here, and you're always, on this 7890, if you look at this control, these emulate the sub base. On the 7812, except for one model of 7890, in 90% of all cases, you will never have wires on the right side of the sub base.
Hold on.
You just have your power, your alarm if you're using it, your main valve, pilot valve, an ignition transformer, and your flame sensing. And all it's looking for is, like you said, is, and while I'm unplugged somewhere, I'll get a flame signal quick. There, okay, it's just looking for your flame signal. You lose your pilot, your main gas valve. They said you don't have to have a main gas valve on there, you see that valve go off. Still asking for main, but there is no main valve out there. It's just a down, dirty control. Real easy to troubleshoot. Now, what you'll see on these though, this is, if you have a standing pilot system, if let me do, I can't do it with this because you have to have a rectification amplifier. The units cannot see flame in the off condition. So what do you have on a standing pilot? You have continuous flame. That's a problem. So what you have to do is if you go to, let's see, you have to go back to that directory and get a chance. And I'm going to show you what you need to do if ever you come across a standing pilot system. Let's see.
Which one, Don?
Oh, the,
I burn wood.
that one, the standing pilot, that one. Okay, turn this off.
You sure?
And this is,
I'll deliver you some.
Microsoft.
Oh, yeah?
365.
It's not any cotton. Or pine.
Oh,
Yeah.
I'll take it.
yeah,
You got a hook in your yard?
Some of the
My mom's
stuff,
house,
stuff
it's like-
Joe runs into.
he does.
Yeah.
5 minutes. I worked on lots in this crap. I'll see what's up, people are taking some, if I have some extras.
Put it on.
I get into that, but
You cutting it for them already? too?
next thing you know, I'm in demand. There's only a few, like, does that work out? Maybe 2 foot, probably 6 foot.
Yeah.
You should.
I
You
think those in the middle make furniture.
I had my buddy come by and grab like the nicest, biggest ones, he's gonna have like, so like a 20-foot bandsaw and all that.
Yeah, yeah. Got mills all around this, but I stack that big straight stuff up.
Yeah. I mean, it's just a
Stuff I
big,
could barely pick up 400 pounds.
12 foot wide, 20 feet deep. 10 foot high. Big. Inside. We're so old. British factory, bro.
What the heck is that? The lighter trick,
It's not gonna let me open it.
He's also the chief of police.
Are you gonna need the PowerPoint up anymore, Bob?
Oh, shit, yeah, you were.
Yes.
punched in my face or whatever, no, it was the FBI guys. Complaining about the FBI.
There we go. Third time was a charm.
So where's the best place in town to go for flame rods and ignition rods? Is Famous still have that aisle back there in the back, but he's, just come back and dig around in the bottom?
Maybe. Actually, they do. Hermetic?
No, I mean, they have some stuff, but. I saw somewhere there was a kit. Do you have one of those?
We did.
It had like maybe 30 different kinds in it.
Probably
Get
just
you out
buy
of a
one.
bind.
Yeah.
Every time I go out, if I gotta change one, I get two and sell them two. Put one in a box.
I had a 4-inch square box with, it was for testing RAA tanks. You plug this thing in there and play with it, you know, with
Yeah, like-
lights and stuff.
He's got one at his place.
Yeah.
Hermetic still got one. Famous has gotta have theirs still, I'm sure.
Well, I have one
Okay.
in my shop.
Right about that. If you are ever changing a standing pilot system, right now, we are in the off condition, the flame is on, normally we would go into alarm. So, Honeywell used to make an RM7890C specifically for standing pilot systems. And because of low demand, they stopped using that, so, and you can use a 7890 like we have here, used for intermittent pilot, but, so what you have to do is you have to isolate that flame signal right here. So all you're doing, you're not using your ignition transformer would normally go on terminal 10, we're not using that. So what we're doing is we're operating this relay, that relay is normally open in the off condition, we're operating that off of the pilot line. So when there's a call for heat,
It's not looking for the flame sense.
yeah. So
Until it's
what'll
telling
happen
you the
is
flames.
when there's a call for heat, you're gonna close that relay,
Something happened.
and it's gonna open up your main valve. You'll see these on like maybe old, if you ever run into one, if they're on old systems, like old churches or, you know, some old, Constellation School or something like that. But that, just a reminder that, that's what you wanna do is if you're going to a standing pilot system, you will need an isolation relay in there to do that.
So if you've got a pilot and you've got no pilot
See,
signal.
I took the call for, I took the call for heat off, and flame is still on, it's not sensing flame, because all you're doing is controlling the main valve. Pilot's staying on continuously.
So if you've got a pilot, you've got no pilot signal, and you might have a bad relay.
I'm sorry, what?
You might have bad relay contacts for the relay. They get
Oh, you
worn out.
could, yeah, or some.
They shouldn't, because it's usually real low
relay,
current.
yeah.
Engineered Air will mess with you that way too. They put their, on their makeup air units, they put their high or low airflow sensors and their manual reset high temperature lockout all in series with your flame rod. So your customer will see, oh, the flame safety's set, I reset it, and no matter how many times you reset it, you see it as a pilot, and you go hit the manual reset on the high temp limit. It's easy if you got the schematics, but if.
So you just have a guy sit there and hold the button.
Yeah. Yeah.
It won't
Till
help
one
you.
time, then you switch to a different guy.
No, holding in the manual reset on the flame safety doesn't help.
No.
It's not, the circuitry's not designed.
Approved for that.
Yeah, it won't work. Where did it work?
Did you work too hard today?
I used it for a little bit.
He's mad about it.
Sounds like 5 minutes.
You were able to,
She wants 250.
Brian had to go take care of something.
Up to 1,000. Yeah.
Boat's not sinking.
I used to run my toolbox.
I don't think for that $1,000.
That's what I'm aware of.
How do you pay her?
Carl and Gary, I don't know if Carl's been to work. Gary's been to work.
Probably.
Brandy usually comes out.
Yeah, he was up at Selma.
Well, she was on her way home.
He had to work until.
Bear with me, somebody, I have to change jumpers because while they're, the power alarm and the power alarm and the blower on different terminals. So just give me one here.
We did get that skin on.
So that's something we can.
We did get that skin on.
They're supposed to take that at home. What? They're supposed to take that home.
Okay, so you did fire it?
I did fire it yesterday, got it up and I had 10 pounds in it and I left last night. Isolated.
So what was operating all night? It ran last night?
No, it ran up until I left it, I shut it down, but I had it isolated from the header.
What one do we have that is spray? Do we have one that reads?
Welder, you said?
Yes.
Thanks. Where are the, so that's ready to rock, that boiler's open now for you?
Remember purple
It's
people?
over and drained, but it'll be ready to rock. Come on in.
Wasn't there a fire alarm or something in spray too that Carl was looking at?
Oh, stand needs to go out of there because it's piped in, they got those little holes. How are we gonna?
We got the handle on the tanks.
Does that something?
The
boiler.
This drain, the boiler you wanna add it to, you can go down a little bit, dump it in the feed tank. and-
Yeah.
Do that, I think your waste was fine.
I don't know where else we did.
Click on the header. There was a freaking tap valve and a plug valve.
Spider.
Going the right way. So the plug valve was broke. We didn't have to do the vacuum breaker. Somebody had a quote.
About those two old maids, one was trying to die. The other
You know
was
where our
trying to-
interface is? Don't we have one of those interfaces, Reese? Where was Sam, we have two? Do you have one?
I think I have one in my office.
Learn that, you fell out about two,
Yeah.
red box, plastic boxes.
But mine's in a box, you need it?
No, I just wanna make sure. You know, it's available.
Do you have an interface? Fine for this? Yeah. You want me to get mine at Terry? Cause I haven't, I'm not.
Either that or we have it here, we dispatch it if somebody needs it.
That would probably be better.
Where's the other one?
I could've sworn we bought
Do
two.
you know?
I don't personally know.
I thought we bought two.
I always
We have
try
at least-
to, I always, especially if a customer's got multiple things, I always try, if he has to replace his control, he usually gets one. Put in the cost of it.
I know we had at least two.
I remember buying two, like, I remember Brett buying one of the plastic cases.
What happened to
Where's
it?
your high plane?
Mike's gonna wake up in the middle of the night and smell like cold cuts.
COVID. Don't like my chips.
Can't believe I'm saying this, but
Now we have a 7895, probably the next most popular unit. This has a, yeah, you could go, oh, you know what, we could close this out. Did anyone have any questions about that, the 7890? Okay, we could close this one out
okay.
and go back to, now 7895. There you go. This is the, this unit is, this is the one that has a blower output. Turn that on. Start up your blower. I should have put a longer purge time in there. I think it's only a 2-second purge. Why aren't we lighting? Oh, we are lit, okay. There is a main on there. Did you see the flame get larger? Oh,
I noticed it before, I was trying to figure it out.
So I could figure.
What do you got, propane tank right there?
Yeah.
start again.
Also green tanks?
There's your pilot flame.
Oh, okay.
And it's gonna do that whole 10-second trial, right?
There's your,
There we
there's your
go.
main, yeah, there's your main flame. Now, if you lose your airflow switch, you can go to alarm. And I don't have the jumper cut, wait. No, that's the wrong switch, I'm sorry. I want, airflow's down here, I'm sorry. But let's do this, if you don't, if you go to start,
You
you
don't
lose your airflow switch, after 15 seconds, it's gonna go, maybe 5 or 15, you're gonna go into alarm. I think it's 15, we'll let it go.
It's blown up by now.
Well, we don't have a gas, we turn the gas on.
No, there's no yellow light, there's the yellow for pilot. It's not trying, no gas. It's just waiting for the airflow.
There you go.
Okay.
Airflow switch is wired
I
in
didn't-
series with the control.
No, it's,
It's just blinking.
I'd have to check the jumpers. I know on the programmer, if you lose your airflow, it will go to alarm. This is not a programmer, this is a flame relay. Now, the only difference, this has the blower output, and it has the airflow input. So if you lose your airflow, it's going to tell you that. A lot of places, oh, you just see a jumper.
I can't remember which one it was. There's one
Next
that,
slide.
there's one that if you lost your airflow, it just shut the burner down, but if it came back, it brings it back up.
This is what I was saying about the
I have one of
previous, the R7795s, where you had specific models for UV and specific models for flame rods. The reason, do you ever see self-checking flame scanners anywhere? You familiar with those?
I've heard of them, but what are they? They're the big, real big ones.
Yeah, the, self-checking flame scanners, you have to have them on burners that cycle in excess of 24 hours without recycling. Because you can have a UV, the possibility exists that a UV could fail, a UV detector could fail in an on condition. So what can happen is, if there's a leak in there, it's a vacuum tube, and it's reactive with oxygen. Oxygen gets in there, it destroys them, and they will, sometimes they fail on. So if it fails on, and you lose your flame, it's gonna say, I have flame, and keep the valve open. So what a self-checking flame scanner does, it has a mechanical shutter in there, and you have a dedicated amplifier that looks for open, close, continuous open, close. So it checks that to make sure that
It's continuously doing that?
Continuously, yeah. And now before, there was
It's
a
like a process equipment that's running like
yeah, it
Meets the
runs
time.
continuously, you have a process, usually in process boilers, you'll see that,
calcine?
or process ovens. But in a C7012, before they came up with that, they didn't have the technology to make a UV out of this unit. So what Honeywell did is they had a rectification amplifier, and they converted that signal to, I'm sorry, it was a UV, and they converted the signal to a rectification signal. Now they have one that integrates both the UV amplifier with a UV flame scanner. Next slide.
So, well, before you go anywhere, you just triggered a thought. What's the difference between the rectification signal and UV signal?
Cost.
Sorry?
Cost.
No, I'm sorry, you said it interprets it differently.
Oh, yeah, okay, this C7012 that you see here, and you can still get them. The C7012 flame scanner, you actually use a rectification amplifier in your flame relay.
Okay.
Only it's a different one, like, these are, grab one.
So regardless, the machine's looking for the same signal, that's what you're saying.
Pardon?
It's looking for an artificial sine wave that you're making with the shutter.
Yeah, it's looking for all, you would see it with your
DC,
flame signal. Let's say it's normally a 5. Typically, you're gonna see, the highest you'll see on it, you're gonna see a 5. So you'll see that 5, and a shutter literally blocks the signal, it'll drop to 0, open back up, it bumps to 5. And it does that about every 5 seconds or so. And that amplifier has to see that signal is going open, close, and it will send a stable signal to the relay itself.
What is it, got like a motor, just a rotating wheel with a block?
No, it's
Like those old Christmas lights?
it's just, if you were to see one, it's just a piece of metal, and it goes up and down. It's like a solenoid, just opening and closing. It doesn't rotate, it's just up and down and up and down. And it's real lightweight, it's, you could blow on it, it would open up. And the only thing it's done for is, the cost is probably at least 10 times of what one of these cost. In this big housing, it's the same, almost the same bulb. It's just liability. Honeywell, I'm not sure about now. The reason all the products cost so much, Honeywell used to be a self-insured, so it was all liability. That's where all that money went in case something goes wrong, so you can pay out,
Permanent light.
yeah. So you'll see, same thing as a 7890, you have limits, controls, your flame detector, ignition transformer, pilot, main, and alarm, and the only difference, you have an airflow switch and a burner motor. So you have one input and one output, extra, over a 7890. And what some people will do is, they need the outputs, but they'll use these, they need those, that airflow switch, and they need that burner motor output, but they'll just throw because it doesn't have a large combustion chamber, they'll just put a 2-second purge timer in there. So, they've come up with something better than that, but, so, next slide. There's your purge timers, your timings, you can get anywhere from 2 seconds all the way up to 30 minutes. and you can replace those at any time. It's always nice if you're working on a system that has like a 90-second purge. So every time you want to test something, you have to sit out 90 seconds unless you happen to have your own 2-second purge timer in the truck. So you're not waiting. We worked on this, some of the industrial ovens, they go out, you could get a purge timer that could go up to, I think it's like 4 hours or something. Now, I worked at, there's a place we worked at where they had the oxidizer we were talking about. It had a 4-minute purge. And every time we had to test it, I didn't have the short purge timer. And they use a different purge timer. It's instead of a ST7800A, there's an ST700C for specific models of these. So you had to wait out the 4 minutes. And after about 6 or 7 tries, you kind of want to call it a day. So, oh, next slide. Here's your jumpers. You see something. Oh, I have the flame failure action switch, airflow switch intact. So it's gonna recycle when I lose my airflow. That's why this was not locking out. If I would have clipped that, it would have locked out. But it's over 200 hours now, so that's my demo, so I don't wanna burn it up. So these, some relays up in the corner here, they don't have, some only have 1 or 2 jumpers, some have 3, but those are where the jumpers are. Next slide.
What's that warning? Is that telling you not to cut it after 200 hours?
Yes, you'll see it.
I've read them.
The keyboard displays you can use on any control, and here's what well, you can see.
No, it's not.
We don't have an expanded annunciator, but your diagnostic information. Now here's where it'll tell you which model you have. You have an RM7895A. Gives you the date code, the purge timer that's in it. Of course, you can just pull the cover off and look at that yourself. The flame failure response time tells me I have a 1-second amplifier in here. It tells you all your jumpers are intact. And it'll tell you the status of your output terminals, your input terminals. And you can go to your fault history, and there it'll tell you your where it failed. This happens to be your pilot flame failed, fault code 28. The fault hours, fault number is fault hour 69. The fault cycle. Sometimes you can see it. Let's see if you have in the last, say, 20 fault cycles. You see they're all failing within a certain amount of time. You know, maybe you could zero out on what the problem might be. So, next slide. You can use any amplifier. The only one is the 7890s. You have to buy a specific model to operate that self-checking flame scanner. Next slide. All of your instructions they'll show you they'll give you a timeline. Starts with save, start, shut. When you go to start, well, go to the next slide and see if it's on that one. It's easier to see. Yeah, there you go. Okay, if you power it up, does your safe start, shut. This is if you have a dynamic airflow switch, but if there's a call to start, it tells you what terminals should be firing at any given point, and what you'll see in the display in your lights if you do not have a keyboard display.
What do you mean dynamic airflow? switch.
That's what we were saying is, in a static condition, you don't, in a static condition, the unit is sitting off.
Okay.
If you have a dynamic airflow switch, that unit wants to see the airflow switch off. It doesn't want, as an example, some people, what they'll do is on a control panel, they'll have their own airflow switch start. They'll turn the switch on, it'll start the fans up, their exhaust fans, whatever. Then they'll cycle this on. And at that point, it's looking for an airflow switch input. Now a dynamic airflow switch is this, if you have a unit that has a 7895 or you have a dynamic airflow switch check, you are not allowed to have an airflow switch input before there is a call to start.
Oh, okay.
I think what was throwing us off was calling it a dynamic airflow switch. It's a dynamic airflow switch
Check.
setup.
Yeah.
Or check circuitry, but you could hook any switch probably to it, a DP switch, paddle switch, the old paddle mercury switches.
Go to the next slide. The C, well, the C is, the Ds are not popular. The 7895C just means that it has interrupted pilot. Only
What
difference.
stays on the whole time.
Stays on the whole time, and you'll see it right, where's the
Who
name?
picked those two names
Right
for the
there,
two
wait, where's the-
Somebody that was just learning English, probably.
No,
Interrupted.
no, I'm sorry, interrupted, the pilot goes out in the 10 seconds into the run period, where's the pilot?
Sure?
Interrupted means stops.
Okay,
Stop.
okay, there's your, wait, where's the pilot? Terminal 8, terminal 8. There's terminal 8. Okay.
When do most house furnaces have it? And then pilot, right?
Yes, they stay, the pilot stays on the entire length of the run period.
Interrupt is the one that shuts off.
Interrupted, shuts off.
Yeah.
Yeah.
What, 8 seconds after main or something?
10 seconds into the main valve. Next slide, I think there's your selectable jumpers, and next slide. That's your jumpers. You can have your pilot flame establishing period, your flame failure lockout, or your airflow switch failure. Okay, next slide is.
That's it. That's all for this one.
That's it? Okay, now we'll go to the 7800 and then we'll just about be through.
The ARP calling?
Duty call.
Where's the wife?
Trouble out. I hope she's not watching on Facebook.
That's under the video.
The furnace doesn't work. All the HVAC, it's cold in here.
69, it's cold. It's freezing. You got one of those too?
No,
No?
not mine. I just deal with those.
Got rid of mine.
That's one
Furnished?
No.
Yep, the first.
Yeah, the wife took the dog and ran off. She missed that dog.
So you got furnace, don't you?
Yeah, I got furnace and no dog.
I might take your brother. None of my dad's asks,
Yeah.
I'm not taking, bring your dog over to my house. Got a fenced yard and everything.
I rope around the deck, tie a tree bumper, you can drag it back.
I like that old when they did that.
Are they gonna get built? You wanna go home
2
tonight?
miles he kept up with it. Played dog tied the bumper. Yes.
That's a good
He's
kind.
gonna shut my sister.
No dog.
So somebody,
Oh, the poor fellow, he kept up for 2 miles and then he
Shut up. Yeah, it's comedy.
Yeah.
Drive safe.
It's Chevy Chase.
Yeah, it's,
You want a meatball for the road?
Vacation.
Meatball for the road?
It's my grandma on the roof.
I swear he's moving. He's on me and he's sore.
yeah, your dog tied a bumper. and
Yeah.
took off.
Yeah.
Just got home, he's off the tire and the wires.
Oops.
Yeah.
I was in Chester, brakes are slow.
Listen, old man, I haven't watched TV in years, man.
You know, about time you did something like that, you know? You start heading toward that retirement.
Retirement,
Yeah.
a long ways to go for that.
Not the way you're beating yourself up, you know?
Yeah.
Look
If
at
I
me.
stay home and watch TV more than 4 days, I'll probably throw it out.
Probably about.
Okay, last we have a 7800, this is a programmer, this does your, if you're using it, this does your, this one's gonna do your high and low fire proven. Gonna do your proof of closure. So if we lose, as an example, if we lose our proof of closure, it's gonna say pre-ignition interlock, it's gonna show you a failure, and it won't let you start. I know it will go into alarm, I just don't have the exact timing on that, so we'll just.
Does that one have fan proof on there too?
Yeah, that has that. So. I missed the jumper, hang on a minute. Let's see, I'm missing 13. Where's 13? This one. Oops.
Where's your delayed ignition demonstrator, Bob?
Behind it. Like a bath fan or something. No! I don't want that one.
Ah.
Not hard to remove.
Hard reset.
Now, where am I?
Hard.
This is hard. This is hard.
Knock the wire out of some of the.
I had one where my airflow proof switch was.
There you go.
Alarm, alarm, alarm.
What we went and looked at was just bad.
Oh,
You need to get your.
It was all white, right? So
You get
airflow proof
the.
switch was fluttering.
Yeah.
That main valves were fluttering. So we're dumping gas out the back of the building.
Yeah, we did that. John was bringing it to all.
I had that one.
That's when it came back from my shoulder. I was long I'd been doing it. Open that door.
Told you about it. Door I can walk in the door around it.
all right.
He just didn't diagnose it fast.
Okay, so we're to call the start, and we are now driving the high fire. It's our firing rate motor. And all that's doing, see, what you'll see most out in the field is you will see a, like, are you familiar with the L91s? That take the 3-wire, it's 135 ohm slide wire. Most of them use those that you see out in the field. I'm using a 4 to 20 signal. Rather than having 3 wires out there, you only need 2. So all this is doing is when you drive the high fire, this unit is putting a jumper inside the motor from your negative signal to your F terminal that drives at the high fire. To drive the low fire, when you open up that to 4 to 20 control signal, and that motor, it drives to 0. You see it's driving to 0 now, and it hits that end switch. It will light off. Get your flame signal there. Now 10 seconds into run, we will lose that pilot flame.
Because you moved the UV.
I moved it to UV, yeah. And actually, these are,
Lining.
if you were to again, let it go off. You can actually view that from a long way. See if it does it from out here.
Yeah, how far?
Long as the
Fire.
wires.
I can't remember, I was
Very
working,
far.
I was working at one of the gas pumping stations, and they had something that monitored your yard, and if you so much as, like if you had to braze something, you had to tell them, if you so much as lit a lighter or anything like that, they had detectors that would, cause they needed to know if there was a fire, like, before. So lightning strike or anything like that hits anywhere in the, but I mean, it seemed like a whole yard where they have those big gas storage tanks and stuff like that. I think those places have ones that just monitor for UV out in the.
I worked at a place that had, once a year, they had to have a UV gadget, $2,500 test gadget, shine it, and it says, hey, there's a fire in here, and set off the fire alarm or whatever.
Yeah,
But
this
they didn't really
scan,
wanna have a fire.
this kind of like scan the property.
No.
Might probably just might be an array of those, you know, in a circle.
Yeah.
You see in the display, there you
There you
go.
go. That's probably a good
flame signal.
10 feet.
Now you can go, actually go, depending on your flame, it can go a lot farther than that.
Longer
Well,
wires.
Wire's not long enough.
It is jumping around a little bit, but that's a pretty small flame. And also 10 seconds into the run, it will release your actuator to,
The controller.
To go to high fire.
I should have set it back up to, set it up to 60%, and that'll actually drive up. But it would have, if it wasn't, I had it set at 0, but anyway. So, and you can see, I'm gonna put it. Oh, we went on. See that. One way to test your flame sensors, you should not see anything in the off condition. You put any kind of flame in there, you see it how it excites there. Or sometimes if it's bad, you will see that on continuously. But that's one way to test that, is you can get a torch or lighter, and even in the off condition, you should see glow orange in there, is it, exciter in there.
Look at that.
Without being plugged to an amplifier, can you still get a flame signal off of that when you're,
Pardon?
if you have a lighter on that like that, can you generate some form of flame signal without an amplifier?
No, you have to have an amplifier in the unit, is that, yes, you have to have
So
that.
you can't test it with a meter on it, is what I'm getting at.
What, oh, you could,
Just
you know,
like-
you could use a meter here.
Right, I'm getting at if you
Just
have
the
one.
sensor by
Right.
itself out
Oh,
of the
no,
box.
no,
There's
no,
way
no,
to
you,
test
no,
it.
you have to have it connected to the unit, yeah.
Amplifier.
No, yeah, I know, guys have said, well, I tested voltages at the output terminals or whatever. No, you have to, it doesn't work that way. I don't know why.
Probably not enough voltage.
Well, no, I don't know the actual design behind the circuitry. It's a proprietary,
It's a powered
arrangements.
device and then it has to see
Yeah, but
UV.
whoever, yeah, it
react
has
to
to, I'm not sure how the voltage goes through there. I know it's a lot different than a rectification, because rectification, you could touch those terminals with your
You're just
finger
looking for a DC.
and not worry, but I think that it's higher voltage on the UV circuit.
Be careful on the rectification with some of that fire eye stuff, cause it's 120 volts and you
Oh,
will feel it.
go with,
Light your fire.
Oh, let's see. Now this one,
It's on.
let me, go back to, real quick on the, just recycle this for a moment. Now this one, this one is, okay, so this one has the airflow switch jumper, it's actually missing, it's not even in there. So it's gonna go to alarm on airflow, but I wanted to demonstrate what would happen is if you had a unit, it would have to be a brand new unit, because you can't cut it after 200 hours, but what you could do,
There's gotta be a time delay built into that for the.
now see, this is cut. And if you lose your airflow switch when there's a call to start, it will go into alarm. So let me reset that for a moment and let it start up. Go ahead.
I had one that, I had a flickering airflow switch, and it was actually chattering the, block and cutout valve signal on and off. It didn't go into lockout, so there's gotta be some kind of time delay. I think it was 7800, if I remember right.
Let this start up for a moment. What I was gonna say is if you had the airflow switch check jumper cut, so what's gonna happen when you go into alarm, or if you lose your airflow on that terminal 7, it's going to go into alarm. And you have to have airflow, the input for the entire duration of your trial period and your run period.
Continue.
So, if you had a.
So if that wasn't cut, then it would just flutter
Yeah.
the
But
valve.
if you had one cut, and you would get nuisance shutdowns, but you don't know where it's coming from. Technically, you could tie in, maybe it's a gas pressure switch that's giving you a problem. You can tie those in temporarily and as a test to see, well, we never had problems with airflow before. Let me throw the gas pressure switch on there, and I will shut this down. Wait a minute, now we're up and, let me get up and running here. Turn this back up to, oh, there we go. Okay. So now it's releasing the motor, and we are up and running. Now we're going to drop the airflow out. And it's going to go to alarm. So if the airflow switch was was cut on a specific unit, or if it's 7800, the J2 jumper is not there anyway, so you don't have to worry about it. You get nuisance shutdowns on something, you don't know what it is. You could temporarily start to tie those in on your airflow circuit, and then you could determine, well, this is causing a problem. We never had a problem with the airflow. I'm gonna tie this gas pressure switch on there. Now all of a sudden you're because now all of a sudden you're gonna start getting lockout 29s. Hey, it never happened until I put that airflow switch or some other kind of limit switch or whatever the case may be on that circuit. So, I don't know what other slides there are, if you want to run through those.
The other ones look like sequencing, right? On these?
Yeah, those are just showing the wiring, and this is kind of these, stop right there, that's showing when it drives, when it drives to high and low fire and modulate inside the unit. It's the only thing there's just two relays in there, there's two separate relays, one drives it high, or one opens, one closes, and that's a series, that is a Series 90 control you're looking at, so you're jumpering from R, to drive it to high fire, you're jumpering from R, high fire. High fire is on the motor, you're jumping from R to B. To drive to low fire, you jumper from R to W on a Series 90 motor. And then when you modulate, obviously you have where's the modulate, there's your R terminal, you can either go to R, where's that Series 90, there's your B terminal, and it makes contact with your R terminal, so there's your Series 90 controller. Go to the next slide. Yeah, now this is if you're using a 4 to, go back. Yeah, this is if you're going to a 4 to 20 input, you only need 2 wires from your, actually 3 wires.
It's on the actuator, it's a 3-wire actuator.
If you want a low fire start, if you want a low fire start thermostat, some people put those in. You would just put some type of thermostatic control, and then you would just put your relay contacts in here if you want to keep it in low fire hold until you got up to a specific temperature to override your actual controller. You want to keep you guys any later than you have to do. I had one more set of slides. If you've seen enough, that's fine. If not, we can run through.
Which one are you looking at?
What's that?
Which one are you?
The flame scanners. Well, I didn't do the valve proving, but I could show you that. But through the flame scanners, turn this off.
So you mentioned infrared before.
Yes.
What is I can't remember ever seeing an infrared, unless we're talking about a UV scanner.
No, actually,
No,
if
it's
you look at the
different.
Infrared's different.
yeah, the rectification will always have a green sticker.
Okay.
The UVs have a purple sticker. The 7861s, which is for the self-checking flame scanner, I believe it is
Sorry, we're
purple,
clicking
but
in and
it
clicking
has it has bold letters to say that it's self-checking.
The infrared.
The infrareds will always be red.
It's the CAD cells?
Yes.
The CAD cell phone?
So that's the CAD cell.
The only
Oil
people that I
burners.
really know
Okay.
that ever use those much
All right.
are
Oil burner.
Cleaver used them a lot, and I think they used to use them a lot on oil, I think. Because if you go to,
Yeah, there's
well,
something-
your thermocouples, okay, a thermocouple is just, this is a thermocouple that's in here.
Heat generation.
Yeah, what's that?
hot one, cold.
Yeah, all you're doing is a thermocouple, it's just, there's just two bimetals in here. And unlike a, thermocouple, as you heat that, you get millivolts off of there. And your controller will read that, it's calibrated, so it knows if it's a type J, type K, type S, based on the input setting. It's this kind of thermocouple, so I got, 3 point whatever milliamps, and I'm gonna get 60 degrees at that temperature.
It's volts.
Millivolts,
Yeah,
yes.
no.
Yeah, that's a thermocouple. So all it is two, go back to that real quick, just two dissimilar metals. There's your cold junction, as you heat that up, it generates the two dissimilar metals, give you millivolts. And that's how that is a thermocouple. As opposed to, next slide, is a flame rod. Flame rod is just a bare piece of metal like this, and go to the next slide, what's actually happening, if you go to the next slide, okay, the requirements for a flame rod, you need a good flame, stable flame, an adequate ground area. They'd say at least 4:1, your ratio. Now we'll see a slide on that. So you see your electrode, there's your flame rod, your ground, the ignition electrode. Next slide. Your flame rod in the flame, although sometimes it doesn't always work that way. Sometimes flame, depending on the nature of the flame rod has to be positioned for best results. Next slide. You need your amplifier. Go to the next one. And what's actually happening is your F terminal is putting off electrons going through the flame. Flame is acting as a switch, and it goes to ground, and that goes back to your flame controller. So go to the next slide. And here's why you want your 4:1 ratio. This is a little shotgun here, and you have pellets, and if you're shooting at the side of the barn, pretty much all of those,
You're gonna hit the
they're all gonna hit the barn. And that's why you have this is your ground area. You want a big ground. Because if you did the opposite, if you were to shoot from here back to this post, maybe 1 or 2 would hit that post, and you're not gonna get a good signal. Next slide. So these are just your response rate, your response ranges and wavelengths. Here's your UV, which is small waves, visible, and your infrared are usually longer waves. If you were to look at a wavelength chart, a light chart from visible and non-visible light. And it just depends on the flame and the fuel. I know if you go to certain chemical plants where they use exotic fuels, you don't use standard flame sensors. They have to be tuned, or you can get adjustable flame sensors, scanners to sense the flame that whatever combustion mixture is being provided. Next slide.
Top fuel flame car.
There's your lead sulfide. We don't, like I said, we don't sell many of those at all. It's the only people that ever really bought them much was Cleaver. I don't know if they used them on oil. You did see them a lot on oil at one time though, where you had I used to see those at the dual fuel boilers that they used to have at old.
They're out
American
there. I've never
Breweries.
seen one running on oil.
Yeah, I
Ever
have.
since the EPA came around and said you couldn't have oil tanks in the ground, I think all that stuff went away.
They have LUST, leaking underground storage tanks.
And it just shows the
Tell your wife about
the
lust.
position of a flame rod that is which one is that? That's
It's the sighting pipe, so it's gonna be a
okay, you're
keeper.
looking at that is the infrared. They're looking at it from an angle. Go to the next one. A refractory can give a false flame signal to UV. So if you have if it's real hot in the chamber, and they're saying that flame shimmer 10 from the refractory can give you a false flame signal.
So that's when you go to the infrared.
Yeah. Or UV, I'm sorry. That is, go to the next slide, this is still.
Which one's more susceptible to the
the infrared.
Yeah.
Yeah. So, yeah, we're still on the lead sulfide, so, they tell you to stay away from hot refractory, and that's if you're looking at the refractory, you might just be looking at open air. And then whoever designs that should know that up front. What material do you have within that chamber? Go to the next slide. That's just the C7015, it is specified wiring. Usually the UV and the infrared detectors, your G is always your ground, your F is always your flame signal. Next one. There's your UV, that's your gas-filled tube. Actually, you know, I don't know how I'd like to see how it's done. Supposedly these tubes are hand-blown. You have a bunch of people in there with, that's what I heard, I don't know, I don't know.
Those lead wires are supposed to be twisted?
No, they don't have to be. Although you do want, you don't want to run those in the same pipe as line voltage, or same thing with your sensing wires for rectification. You want to keep those isolated, or if you have to, put them in shielded cable.
Yeah, shielded.
Yeah.
So you'll see an induced voltage is what you're saying.
Yeah. Or you could just get some kind of electrical noise.
Spurious stuff.
You know, you don't know.
Yeah, glitchy loss of flame.
And then they're showing the detector for a UV. They're showing it at a 90-degree angle, although it doesn't have to be at 90. But next slide is, yeah, now they're showing the C7012, C7061, and those are the self-checking flame scanners. Like I said, it's the same thing as a UV, a non-self-checking UV, except it has that shutter.
So can you convert pretty much any burner by changing that in the amplifier?
Yes, you can. Next slide. This is a good point now, right here where it says it's your flame detector. Right here is if you have a UV detector, and this is a Honeywell Q624 ignition transformer. It's called a half-wave transformer. And you know what that is? I can explain that if you don't. What that does is on a
It's rectified, so they use a DC.
So there's your sine wave. When it's with the Q624, as it's powered, it only puts that spark out on half a wave. Because with the that amplifier will see that, if it sees that full wave, it could, when you're going to light off, if you have one of those big iron chunks out here, and it's, you know, those big iron transformers, and it sees that spark, it could determine that or as a flame, and it'll lock you out while it's trying to light off. So if you ever have that problem, get a Q624 and it'll solve that problem.
Well, if the ignition transformer is on it, the pilot gas should be on at that point. Don't they usually come on in parallel?
Well,
Pilot.
yes and no.
I've seen a lot of them wired that way. They come out of one terminal and they go to both.
But I'm saying the possibility exists, if you have that problem and it sees that from a standard full wave, like your Allinsons or Dongans, just a big 6,000 volt full wave transformer, and you're having that problem, just change to a half wave transformer, and it will solve that problem. Go to the next slide. Optical detectors. Those are just some recommended guidelines. Go to the next one. There's your UVs, purple peeper, and your large flame scanner. The next one, it just shows you the different types. The R7847s are always rectification. The 7848s that was the original the original infrareds, but they've gone to a solid state now. It uses a C7915, a C7915 flame scanner, and an I think it's a 7851, yeah, 7852, I'm sorry, amplifier. Your Purple Peepers use an R7849. Next slide. Then you have, there are 7849Bs, 48 and 49Bs, and all that is, they call it an AmpliCheck. And I don't know if they're worth the money, but they cost a lot more, but supposedly they check the circuitry within the amplifier only. I don't know what circuitry can go bad, either it's good or it's bad, but it is the dynamic AmpliCheck, right there, amplifiers are not a self-checking amplifier. So if you go to the next one, next slide.
That's it.
Oh, wait, yeah, okay. Now, this is a true self-checking flame scanner. It's a 7861, and it uses R7861 as the amplifier. The C7061 is your flame scanner. That is a matched pair. This one here, the R7886. And
What's the F?
Oh, that's
a bigger version.
That's explosion proof. So if you're in an explosion proof environment, and we all know the cost from a standard electrical device to an explosion proof device, yeah. So you're talking about
Multiple.
this probably cost $1,000, and this is probably about $3,000 or thereabouts. So you got an awful amount. The R7886 and C7076, that's what I was talking about. This is a specialized flame scanner that you would use for some type of exotic fuels, or in some processes they may start with fuel A, and during the process, well, we're going to keep this burner lit, but we're going to go to this mixture of gases that has a different wavelength, and those are adjustable. The only time you'll see those, the only place I know that uses those in our area is a place out in Grafton. It's called Ross Incineration, and they run all these burn-off ovens for if ever you have a bad load of tanker load of chemical, you bring it in there and they will burn it off for you. So it's safe. Next.
That's it.
That's it. Okay.
That's it.
If you wanted to go real quick, that valve proving, might as well do that too. That's an easy one. That's all on one slide with a couple tabs.
Well, that's on our Excel spreadsheet.
Yes, you're right.
Why is
Okay. If you go to the README, first tab right there, there's kind of a diagram we were talking about with the valve proving. There's your pressure switch, there's your first valve, your second valve, there's the downstream cavity of the first valve, the upstream cavity of the second valve, the distance of pipe in between, diameter, so you just need to know all that volume. And it's part of your calculation. You go to the next, go to the formula. Let's just, and I made this up. Put a Y, a uppercase Y. Oh yeah, put the number of feet. Put like 2 feet. Put a 2 in here, and then put an uppercase Y in this 2-inch. And let's say the gas inlet pressure is, say, I don't know, 20 inches of water count. And the total, put 2 million BT, you have to put the whole 2 million in there.
here?
Yeah. And then put another Y in the V5055. That one right there, uppercase Y.
They're right,
To the
two
right.
more
To
rows.
the right, there it is.
The Y in there, and go down, let's see. It's telling you your minimum test time is, you would program that, there's a section there, if you had a flame relay with the valve proving feature, there's a few Honeywell relays, and you use a special, not a special, but you use a different keypad, you could program that time in there to do your valve proving.
How do you find out what it is if somebody else did it?
Well, it's keyboard, it's passcode protected.
Is there a way to read it though and find out what it is? If you
Oh,
go
yeah,
to replace
yeah,
the
you
control?
could go in, you could go in and read it, but you still, to get
You
into it.
can't change it unless you have the passcode.
Yes, that's correct.
So if you're gonna.
You wouldn't even be able to read it without the passcode.
Oh, well, that's what I mean. So how would you change, you'd have to redo all these calculations every time you go, like if somebody else put all this in and then you come along and go to change it?
Yeah, you'd have to know the code to go in and change it.
The company we just stole the account from is not gonna give us.
Well,
None of
usually, no,
you-
it's only a 2-digit code, usually people don't change those, I can't believe anybody's that anal that, yeah, I'm gonna change the code, so nobody could get in there.
Be
Oh, they do.
surprised.
Yes, they do.
So what's the 2-digit code?
78, that's 7,800, 78. So that's, pretty much it for tonight.
Wow, thank you.
Oh, I went a little longer than I thought it would, but, we, thank you.
I know you put a lot into it.
Oh, okay.
I hope they like that.
We had another capitalized and lower case.
We told you what goes on there, we'd have to kill you.
Oh, we're gonna get locked up.
Good night, gentlemen.